So, hello. Sorry I couldn't be here today, so I figured this is the best way to get the notes through to you. So this is all about direct variation. The only thing you really need to know about direct variation is that it's still this equation, except this is always 0. So that's always 0. Okay? Keep that in mind. It's still y equals mx plus b. It gives you a line. It's just that it always goes through the origin because the y-intercept is always 0. So I get a little crooked here. Let me see if I can fix this. All right, that's a little better. Okay, so definition, direct variation. Y varies directly with x. Y equals ax. This is really the slope. They're just using a different letter. They're using a instead of m. It's still the slope. Sometimes you'll even see it as k, which stands for constant of variation, which I'll tell you. And then constant of variation a is the same as slope. It's just got to remember that's the number that doesn't change in the equation. Okay. All right. Yeah, there is a warm up here. So just as usual, take a moment to do it. I'm going to freeze this and then come back to it when I have it filled out. You'll see all of a sudden you'll see the questions filled in. So pause first. Okay, so hopefully this is what you got. Now, those two were pretty easy, I'm hoping. You're just solving for a there. This is a direct variation equation, so is this, but we'll get to that. All right, write an equation of a line that passes through these 2 points. Well, you notice right here that this goes through the origin. The y-intercept is 0. You still have to find the slope by doing change in y over change in x, which is 2. So I wrote it in y equals mx plus b form. You can write it with the 0 or not. Most of the time you'll see it without the 0. So y equals 2x. A flower is 4.5 centimeters wide and has a leaf 7.2 centimeters long. What is the ratio, which you should leave as a fraction answer, of the flower width to the leaf length? So when it has the 2 here, the width goes on top and the length goes on bottom. This is the answer as a decimal, and you can just convert it to a fraction right on your calculator. So hopefully you left your answer as a fraction. Okay? All right, let's start this doing some direct variation. Again, you just need to remember it's really the same as this, except that the y-intercept is always 0, and these lines, these direct variation lines, will always go through the origin. Okay? So, write a direct variation equation that has the given point as a solution. So this is the direct variation equation that you're going to use. And what you need to do is you need A to write any direct variation equation. It's like solving for the slope. You need this to write the equation. Well, here they're just giving you a point. And you may say, well, how am I going to do that? Well, if you need A, and you think about this, you solve for A is just equal to y divided by x. And you have an x and a y here. So you can solve for A in this problem. So you just do the y divided by the x. It gives you 3. A equals 3. And you can write the direct variation equation for this. Remember, all of them go through 0, so the second point would be 0, 0 here. There is the direct variation equation. Again, all you need to do is you need to solve for A. So here, same thing. You have an x and a y. You need A, so you divide y by x. Negative 2 divided by 6 equals negative 1/3, and that is my A. So now I can write the equation. Y equals negative 1/3 x. Okay, extension question here. Let's think about what 2 quadrants would this one go through? So think about it, think about it, think about it. Do you remember the quadrants? So if I draw this like this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay? If the y-intercept is the origin, and you use this as the slope, you go up 3 over 1, your line is going to go through here. Oh, Sorry, I'm off. It's going to go through here. So that means it's going to go through quadrant 1 and 3 when it's positive. On the flip side, this also goes through the origin, but since it's negative, it's going to go through 2 and 4. It's going to go down. No matter what angle, it's still going to be in 2 and 4 if it's a negative slope. Do you need to know that right now? No, but you will eventually. So think about it, okay? All right, turn it over. So you're going to often see in physics direct variation equations, and this is a physics law. Hooke's law states that the distance d a spring stretches varies directly with the force F that is applied to it. If you think about it, you have a spring and you're going to hang something heavy on it, it's going to stretch. And then when you take it off, it's going to go back up. And the force that's applied affects that stretch. So I'm going to kind of write down what I know here. D varies directly with the force applied, meaning the distance is affected by the force. So D varies directly with the force. Okay, so that's your equation. So suppose a spring stretches 15 inches, so that's my D. They're giving me the distance. When a force of 9 pounds is applied, that's my force. Write an equation that relates D to F. Remember, force affects the distance. So this is the dependent, that's the independent, okay? So let's write this down then. D equals A times F. To write the equation, I need A. I need A. So I'm going to plug in what I know. The distance is 15. I don't know A. I know F is 9. I can solve for A. A is equal to 15 divided by 9, which reduces to 5/3. Now I can write my equation. Distance that the spring stretches is equal to 5/3 of the force applied. And that's your equation right there. Predict the distance that the spring will stretch when a force of 6 pounds is applied. So they're giving me the force. So I'm going to plug that into my equation. Distance equals 5/3 F. I'm going to plug in the pounds that they told me of force. And when you multiply here, all you got to do is take the whole number times the numerator, which is 30, divided by 3, which gives me 10 inches. So with a force of 6 pounds, the spring will stretch 10 inches. Okay, the one last thing that you're going to have to think about here is deciding whether a set of points displays direct variation. So the dimensions of 5 rectangles, 1, 2, 3, 4, 5, each with an area of 24 square feet, are given in the chart. Tell whether the length and the width show direct variation. If so, write an equation that relates the quantities. So you got two things to do here. First, we have to decide if it does show direct variation. So remember, if this is the direct variation equation, okay, and we notice that to find A, we have to take y divided by x. So to decide if a set of data represents direct variation, y divided by x has to be the same for every point in the table to show direct variation. Okay, I didn't mention earlier, but A is also considered the constant of variation. So you're deciding if the constant of variation is consistent throughout here. So let me show you what I mean. Okay, so here's the first set of points. So I'm going to do this. I'm going to do A equals y divided by x, 24 divided by 1. For this point here, x was multiplied by 24 to get y. So that's my A. Let's see if it works for the next point. I have to get the same number for the next point. And you can probably see already it's not going to happen. 12 divided by 2 is 6. Okay, so these are not the same. You can stop right there and say, no, it does not show direct variation. Okay, all the way across the table, when you divide y by x for each point, the number has to be the same for it to be direct variation. Sometimes you're going to get them where they're going to be really, really, really close decimals. In that case, I would probably say yes, but most of the time it'll be pretty clear. So this is another thing that you're going to have to practice on your homework. Just always remember direct variation. Those lines always go through the origin. Their y-intercept is always 0. When it says A, it's really the same as finding slope. Sometimes in the book they may call the constant of variation K as well. Why they use all those different letters, I'm not sure. All right, behave, because I know how to box. Signing off.